So this here is a galvanometer. It basically has a wire going around this metal cylinder, and as the current goes to the metal cylinder, it becomes into a magnet. It reacts with this magnet and gets deflected, showing that there is some current going through here. So it's basically like a little current detector, simple ammeter. Interesting things to see is what's electromagnetic induction. If you took a piece of wire and you wiggle it near a magnetic field, what you'd be doing is you'd be causing a force on these electrons to move in one direction, hence causing a voltage, causing current to flow. So by wiggling or by moving a wire near a magnetic field, we can create a current. And it turns out that it, as long as there's motion and the amount of magnetic field going lines through the wire is changing, as while it's changing, it creates the change in this um, in the current, but there's no current flowing if this is not moving. So you require the motion. So here's an example. I take a magnet and I stick it into this coil. Because I'm changing the magnetic field around the coil, it makes current flow through here, and that current flowing will show up on the ammeter there. Now, the faster I move this thing in and out, the more higher current I'm going to get. So it's got to do not just with the strength of the magnetic field, but also with how quickly you move it through there. Here's a really cool item. It's a flashlight that you simply shake it to give it power, because what you do is you cause the magnet to go through the coil as you bounce it back and forth, and that causes current to flow through the coil, hence lighting up your flashlight. So it doesn't require any batteries, and it uses this process, and it's called electromagnetic induction. It was Faraday who showed that if you take a magnet and you move it near some wires, or move the wire near a magnet, that you would create a voltage in there. It's how our transformers work. Again, you create a field here. The wires, the current going through here causes electric field, the magnetic field to go through this rod, this thing, and this iron core, and this is transmitted through here, and that causes current to flow back here. So this current here causes a magnetic field here. That magnetic field causes current to flow there, and so we have input and output from a transformer, which either steps up or steps down voltage. There's pictures of typical transformers. Sharks use the magnetic field of the earth to navigate. They use a form of magnetic induction. We see motors. Motors are basically created the same way. We pass current through here, making this into a magnet, and that causes repulsion and attraction and makes this thing rotate. So electric motor converts electrical energy to mechanical energy, while a generator does the opposite. It converts mechanical energy to electrical energy. And those are two things you should know. Okay, what electric motor does, and you naturally know, you put power in it and it turns. So it's converting electrical energy to mechanical energy, motion. And a generator, you rotate the generator and it causes electricity. And so there you're changing mechanical energy to electrical energy. Maglev trains, again, work at the same principle of repulsion. So these things are floating on top, just like two magnets floating on top of each other. You see that electricity and magnetism are two sides of the same coin. A changing electric field causes a magnetic field. A changing magnetic field causes electric field. And that's really how photons are created. Here are some areas where magnetism are being used for various things. Here they're used to slow down these things, so basically using repulsion to slow it down. Key ideas: all magnets have a north and a south pole. Magnetic field lines come out from the north and go into the south. Magnetic field lines never cross. Magnetism is created because of moving charges, and some magnets are temporary while others are permanent. And you know, we need to know a little bit about the direction of field lines and things like that. Okay, so that pretty much wraps up our thing on magnetism. Please feel to reach out to me with any questions on Remind or Schoology or by email. I'll talk to you later. Bye for now.